Hello, yeah. I'm Andreas from Red Badger, so welcome here to the meetup. In the next 20 minutes, I'd like to introduce you to AI from a human-centric point of view. At the moment, AI discussions are very technically driven. That's why I thought it's very important to get like a human-centered view into this topic. And of course, as designers, we want to ensure that these new agents that we build are built around in the benefit of the human. And if we get this right, of course, the promise is quite big. It could make the tools we design and ourselves much smarter, safer, and more effective. And yeah, we will be looking at the AI that's in the world today and at the challenges that are waiting for us. So, hello, it's me. So what we know about AI is very much informed by the movies we've seen, by the sci-fi movies sometimes. So there's like amazing hopes and fears in there. In general, the idea of a learning machine has been around for quite a long time. It was called cybernetics since the 40s. And discussions in the media are either very simplistic and fear-mongering or very technical and complex. So there's a bit of confusion. So I'll just clean up with that a little bit. So a definition from Wikipedia says AI is an intelligent agent that perceives its environment and makes decisions to maximize chances of achieving a goal. What I take from that is that there are 3 stages in that. It's like a perceiving mode where we kind of sense the environment that we want to react to, a processing mode, and then it's like kind of an action mode. And it's like an umbrella term, artificial intelligence. Under there are all the things you might have heard, which is machine learning, visual recognition, natural language processing, speech-to-text, text-to-speech, language classification, that we can read out moods in language, all these things. And where are we today with this artificial intelligence? So there's a classification of artificial intelligence. The first one is called artificial narrow intelligence. That's the AI that's in the world today. These are dedicated systems. They can't generalize. That means they cannot apply what they know from one field to another. That's the limitation. And these are things like the Roomba, these vacuum cleaners that cruise your house. They learn how your furnitures are arranged when you're out of the house, so they have like free range when the cats are sleeping. I don't know, all these things. Go back to the charging station themselves and just pipe up like every 2 months or so, say, hey, the thing is full, can you please clean that? And then they just go on for another 2 months and I don't have to worry about that. So that's the first step. That's what we have today, essentially. Then the next sophistication in that would be artificial general intelligence. That is the stage when it reaches human-like intelligence, the ability to apply intelligence to any problem now, rather than just one specific problem, similar to human intelligence. That includes learning, planning, decision-making, lying as well. That's an interesting one in children development as well. So lying is an important one, making jokes. And the estimates for having anything like that we might have it in 23 years or in 50 years or never. So that's quite interesting compared to how it's depicted in movies. So these are the robot, human-like characters, really. And even more in the movies, really depicted as AI, is what is called artificial superintelligence. That's when the capabilities of the system surpass the humans and they're able to reprogram themselves. So they are able to improve and reproduce themselves. And that's seen as a tipping point. Sometimes it's called the singularity, when like the normal rules of how we do things. That's potentially the last machine we need to design, because then the machine can take care of that itself. But again, that's like, some people say it's 2060, other people say it's coming never, so it's like far, far out. So these are like Samantha and Her, for example. Like she's having multiple conversations with multiple people, and in the end just disappears somewhere to do something that's not comprehensible for us really, so because we're just humans. But again, it's like far, far out. It's, so these two we don't have to really look at into the things we can use at the design. So the first one is really the one we do, and to start with the practical bit, to ensure that the things we do are useful, I wanted to take a big step back, just very generally. How have we evolved our tools? The tools we use, how have we done that as humans? The first stage in there is like to reduce physical effort for us to perform a task. So instead of doing that with a hand, perhaps we get like a big hand or something that amplifies our physical strength. Yeah, when it's working, it's ready to hand, and design focuses on strong affordances and real-time feedback. So that's typical product thing. So the affordances speak of what it does. Real-time feedback is how hard can I hit it, what's working. Then the next stage in this category is power tools, to just have like more strength and make our life easier really, to not have to work that hard to do that. The second class in this tool evolution we have as humans is we've been busy with reducing our cognitive efforts. And this is the part that's really, really interesting for the design that we can build with AI at the moment. So there are two things in there. So one is an assistant that is, for example, this vacuum cleaner has sensors in it. You probably have something like that at home. It knows if it's put against wooden floor or, oops, against a curtain. If it's against a curtain, it throttles its power automatically. But I still need to hold it in my hand. It's part of the user's attention. It helps us with the information work and to stay without known rules or to work along the specification. But it's like very much like helping to, while I perform the action, to do that I can perform the action better. But I need to do it actively. Agents like the Roomba are different. So when the agent is working, it's out of sight, and design must focus on completely different things because it's working itself. It doesn't have to give me feedback at the moment. We need to focus on easy setup and informative touch points when it pipes up to say clean my back, or I'm stuck on the chair or something like that. So these two are really interesting. So assistants and agents, and there's a guy called Christopher Nussel. He's managing director of an interaction design studio called Cooper. He wrote a fantastic book. It's called Designing Agentive Technology, which I can really recommend. He says, as a definition of an agent, it's a persistent background service that watches data streams for triggers and then responds with narrow artificial intelligence to help users to accomplish some goal. And what is my key, what I thought that's really, really interesting is the point he made there is that automation has the goal of the removal of the human from the system, but assistive and agentive technology is explicitly in the service of the human. So that's really, really interesting. That is a very big difference conceptually for how we can design these things. So where are we today with these applications of artificial intelligence? So we've seen all these machines playing chess for lots of times. It's always like, oh, somebody was beating the machine has beaten our chess champion. A few weeks ago, another incredible thing happened. There's a Chinese war strategy game called Go. It has 10, and then in the potence, it's 170 possible board positions. So it's very, very complex. And the DeepMind has built AlphaGo Zero, and within 3 days, the system has managed to beat the world champions in these things. So it's very, very, within predicted rules, it works really, really well. Some people say, it's a brute force technology, so they just achieve that through huge investments in hardware. So it's not really that smart, but still the outcome is really, really good. And for discovering like these rules, potentially discovering anomalies like fraud in a system for like financial banking or health, like indicate like any health issues. That's where we are with this very linear rule-based things. And something else that's a bit more subjective is, and you probably use it all the time, it's like Spotify, your weekly playlist. That's like building patterns on what people like, what people listen to. And they do it, for me at least, very successfully, to put really good lists together. So that's like, just because there's so much stuff on the platform, so how do you curate these things? It's like, that's really good. I've helped. Facebook feed is the same, so if that wouldn't have been curated in some form, it would have been like on average 15,000 messages a day. So it creates a bubble. I mean, it's controversial in itself, but that is the topic as well. So staying with Spotify, they just launched a Facebook bot where I can join with multiple people to create playlists collaboratively. And the bot is facilitating this, is helping us to co-create and do these lists together, which I think is really interesting. So bots, of course, is something that is very close. We can work with that quite soon. When it comes to more complex things like pattern recognition, there are really interesting experiments. So for example, Google has this AI experiments, and one is a bit like, I don't know if you have that as well, it's called Monday Painter. You draw something and the audience has to guess what you're meaning. It's a bit the system does that for you. You draw some shitty dragon and you get like lots of, did you mean a cool dragon, a teddy bear, or something else? Or like a parrot or something. So what's quite interesting here is that it can detect these patterns, and while you play with that, it's nice, but you're giving them, of course, you're training the agent as well to do better predictions as well. And then there are things like that. Systems still get it wrong very often. There are loads of these examples if you Google things like that. They're called crimes against AI. It's really funny. There's like loads of them. Chihuahua or muffin. The system gets it wrong pretty often, actually. So these are the things where I think we're still learning. We're still very early on. And this one here is like the Microsoft agent Tay tweets, which, yeah, went from being a really nice person in 24 hours, it went to be like a really stupid racist. So, and we have to remember that the machine learning algorithm can only be as good as the training data it gets. So they had it on Twitter for 24 hours. And if we have training data that is biased, of course, we just repeat and reinforce the biases that we already have. So we have to be very, very careful what happens there. So sometimes stuff blows up. That's, I guess, as part of any new technology that will happen. Did happen here big time, happens sometimes smaller. When I thought about that, it reminded me a little bit of early SatNav days, where these systems were really young and just coming out, and it guided people to, I don't know if you can see that, they drove into like harbors or something because they just looked at that and it was really bad. The car was broken, obviously. Hopefully nobody got damaged. But now we use these things for 20 years perhaps, and Google Maps is around for 10 years or so. And actually, we get quite comfortable with that. Actually, I trust it quite a bit. And I'm curious, who of you would trust, if you imagine last time you got lost in London, would you trust more a bypasser you ask for directions, or would you rather trust your preferred navigation app? So who would trust your app more than a person? Yeah, loads, yeah. Well, we've learned that it works. And it earned our trust. So I think fair play. The hope is that it happens with other technologies as well. And perhaps it's time to welcome the machine on your team in some respects. Because machines are great at many things, really. So they have a perfect short-term memory. And the memory is erasable as well. So you don't have any of the psychological biases, which are like primacy, recency, all the things that lead us to wrong decisions, potentially. It's just all the things how our mind can be tricked. It can respond to stimuli with great speed and precision. It's very consistent across repetitive tasks, and it doesn't suffer boredom, luckily. So it's great for number crunching and all the things which are really like lots of repetitive and data-driven things. Humans are not that great at these things. They're great at other things. We can improvise. We can apply flexible procedures in pursuit of a solution. We can apply our learnings across contexts, which machines can't do yet and probably can't do in the next 23 or 40 years that easily. And we have easy access to the collective memory that we have gained over our lives by something that's called Gestalt. So it's quite an abstract thing. So we're quite good at these things. So playing to strength and the capabilities is one dimension or one thing to consider when thinking, okay, which part of your product journey should be augmented with artificial intelligence. But there are other things. It's not necessarily just because you're bad at something you should hand it to the machine, because there's like other factors. And that's where designers are really essential with the human-centered perspective, really, to make sure this stuff stays in the service of the human and it doesn't blow up as often. So can the user reasonably delegate a task? I mean, that's pretty simple sometimes, really. It's like if you want to learn a language, that's like this decision tree goes like, is it an assistive or an agentive service, essentially? So if you want to learn a language, of course, you can't reasonably expect the machine to learn the language for you, so it can't be an agent. It could assist you to learn it better, but it can't do the learning for you. You can't send your agent to the gym, right? So you still have to do that yourself, unfortunately. But some people are very eager to apply it for all kinds of things. So it's good like to explain what it's good for, what it's not good for, when it's appropriate to use it and when not. The trigger, is it based on subjective judgment? If it's not very black and white, okay, now we start a thing, then the trigger moment and probably the execution, because you have the loop to track it as well, should be handled by humans. And is user input needed? How often to work in the service of the human? So these are the things, how can we design these journeys? What's the narrative we have? And yeah, there's still loads of challenges, and that I think is really exciting for us to look into this field. There is ethical and unethical applications. So the first one is like the Microsoft thing, of course. Well, I trust it's not intentional. So I mean, they spent money, it's a thing. The other thing is like, how is it put to use? So in China, there are at multiple crossings. There's lots of jaywalking. People just walk the streets all the time. Sometimes accidents happen. So people thought it's a really good idea to have facial recognition on these crossings, identify the offenders, and the system within 20 minutes posts on this board of shame a photograph of the person, really big, together with their passport number and their home address. As well, they post on all the social media feeds of the person, because they can. That was submitted to awards because I think it's very successful for what it was intended to do. It reduced, during the time it was adopted, it has reduced jaywalking per day from 200 cases to 20 cases per day. So it has worked in a way, but of course for us, privacy is a high value. So for us, of course, it's very concerning to do things like that. But it's like, of course, it's our value system as well, but it's like in general, I think there are things which are good, which are questionable in this application. So again, it's very important to have like some voice and some decision. I'm sure policies have to catch up with some of these things as well. I mentioned medicine. on the counterpart is something that's like has really high hopes to like catch cancer prevention, like all these things, which together with Watson is done in India now to a very low price. And yeah, that's really interesting. So some people say, oh, when we have many things are taken over by technology, where is the warmth, where's the human interaction, all these things. But of course, we have to consider as well that if that can be done for relatively low cost, in countries where people don't have this much money, it will still give them access to cancer prevention, for example. So perhaps we have to question our own privileged bias in the West as well, that we can afford to have all these human interactions all the time. Another great example is IBM partnered with the weather company, that globally the biggest network of weather sensors, so air pressure, wind, heat, all these things. And they use machine learning to detect early signs of hurricanes, of floods, and all these things. And they can securely reroute airplanes and container ships to have less accidents, and hail, all these things, which are really dangerous for airplanes. And as well, they reroute according to weather, so wind, for example, if you're on the sea like for 2 weeks to ship something somewhere, if you have like a route that's less wind battered, or you can even take the wind, or airplanes as well, we can be much more energy efficient in this area. So really, really exciting, cool applications. The next one is trust. I mean, we kind of, that's a big one. So we have seen the Google Maps. So many people raised their hand, they trust it more than humans. But how do we know that we can trust the system really? So I guess to know how we trust the system, we have to understand how it thinks and how it learns. And the definition of machine learning is that it's the science of getting computers to act without being explicitly programmed. So that is really interesting. So in machine learning, of course, you have supervised learning, which works with labeled training data. That's pretty straightforward. We know a bunch of data, that's expected outcome, that's a positive result, make a match. There's unsupervised learning, which works with unlabeled training data. So it builds its own functions to solve a challenge. And then, of course, it's deep learning that's more like inspired by neural networks and gets even more abstract. But it's harder to kind of trace its thoughts and decision processes, and that's a very big challenge. So for example, NVIDIA partnered with Audi here to learn how self-driving cars work. So they observed human drivers, the machine, and they made their own deductions. So that's deep learning for the visual tasks. So for road signs, for the lanes, and obstacles. And at some point, the car just stopped, and nobody knew why. And then people thought, actually, we need a debug mode or something like that. So, and they discovered that the roads they've been driving on were always like lined by a nice green strip of grass. And suddenly, the green strip of grass wasn't there, and the car got confused and said, well, I'm not sure, is that a street, is not a street, I just stopped. If we don't understand what it's thinking, how can we entrust it our health or our money or whatever? So it's a really big thing. Last month in MIT Tech Review, this guy called Daniel Clement Dennett is an American philosopher and cognitive scientist, said explainability is the key stumbling block with AI at the moment. So no matter how clever a machine seems, if it can't do better than us in explaining what it's doing, then don't trust it. And the algorithms need to be more transparent, so it's understandable to their creators and accountable to the users. So we need a debug or manual mode, really. Is it something that's safe to use, to publish? And as a user perspective, can I entrust my health or my finances? The next one is AI is not a widget. Sometimes it's portrayed as something that you can just, you have your service flow. Oh, this is number crunching bit. You can just slot it in. It's not quite that easy, because it influences the entire ecosystem if you inject it there. Take self-driving cars. So, of course, it will change how energy is provided and consumed in this area, but as well real estate. So probably in inner city London, we don't need the parking spots anymore, because these things, when I don't need them, they can just drive in front of the city, park somewhere else. And at night, they could have side jobs. They could be a taxi, perhaps. They could make me money. Or, well, perhaps I don't even own the car anymore. Who owns the car? It's really interesting. Perhaps it's on demand, like we have now more. And we need new policies, of course. So what happens if this thing makes an accident? What happens there? Who's responsible? Is it the owner of the car? Is it the producer of the car? All these things, policies are just catching up with all these things. That's like a physical thing that's coming soon. But it's even for digital products where we apply machine learning. We need policies to kind of give like a framework for that. Who's responsible? And explainability is a very, very big topic for that. And similar in health. So it's at Great Ormond Street Hospital, there's this great children's hospital. They have a professor who's dedicated to the topic. And he was at a panel discussion at the Watson Summit a few weeks ago. And the guess is that in 5 years, 90% of all critical medical decisions will be augmented with artificial intelligence in some shape or form. That's really interesting in two ways. So one is like the policy point of view again. Who's responsible if the doctor overrules the advice from the machine? What does the insurance say if they suggest a treatment plan with 95%, but the doctor has a feeling something is not quite right here, so perhaps we shouldn't do that? Who takes responsibility? Is it the doctor? Is it the machine? And what does it mean for the role of the doctor when he works alongside one of these super powerful agents? How is his role different? Is it more the empathy, the things between? Who has the last say, really? It's very interesting. So it's not a widget, it's adding AI, changes the entire ecosystem and how the game is played. A really nice summary comes from Louise Down from GDS. She said at the service design conference a few weeks ago, she said, technology shows what can be done, design shows what should be done, really. So again, I think it's very, very essential that although it's complicated and it's very tech-driven conversation and things might get ugly at some point because it's new technology, but it's very, very important, I think, that designers get into there as well to guide the discussion and make sure the things that get built are built in, around benefits for the humans. So 5 quick takeaways. So consider the effects on the entire ecosystem. It's not just a widget you can slot in, so it's end-to-end view. So service design is really greatly equipped to look at things like that. Make the algorithms transparent, because for accountability and to earn the trust and generate the trust, that's very, very important. Physical products and of course, and our digital products have affordances. So I see that's a handle for opening a door. We don't really have that for these systems because it's a box with a camera, and how do I use that? How do I know I have to draw something and it shows me something else? Or so we have to kind of create these new affordances, which are quite, will be new. We have to sharpen our senses to help the agents to do its perceiving or seeing, simplistic speaking, seeing better in better ways. So that's like visual recognition, text recognition, speech recognition, all these things that make the input of data really easier. Then the performance, what can we learn from this data, really? So can we learn the moods? Can we learn like the situation? And yeah, the last one is just to raise the human-centered voice. Yeah, let's get part of this discussion. I think it's very, very important. And I think if designers don't represent the humans or the users on the table, I think nobody else will. And the opportunity is that the tools we build just become like smarter, safer, and more efficient if we get it right. So yeah, thanks. Do you have any questions? Yeah.
Talking about trust, and I recently read an article that Google got into a bit of trouble because their smart home speakers.
Yes.
You ask them
Mm.
which is a very different experience than Googling it, because then you kind of see all the things.
Yes.
But now it kind of becomes a source of truth.
Mm.
On the other hand, if it will just read an entire list of things, it wouldn't be as useful. How do you balance those two things when designing the experience?
Yeah. It's really interesting because imagine so yeah, the question, yeah. So the question was when, for example, Google has this little voice assistant and you ask a question, it only reproduces the first result. If it's more abstract, it's not like as a clear-cut answer. It doesn't give you a list of possible things to kind of give you a more balanced view. I think, yeah, I guess it's a question, we have to learn these kinds of things. So I wouldn't say it's bad intention necessarily. It's just like, imagine you ask a question and it comes, it could be this, it could be that, it could be that. And in your living room, it takes like 5 minutes. Do you want that at the time, or is it something you switch to the machine? How do you know you have to switch? How do you know it's not the full picture? These are the missing affordances that I think is really important. How do we teach people these kind of things? How do we build these new contracts with these agents that we know how to use them? I think that's what we need to figure out and see what works, what doesn't work.
It seems like that story that this guy just said, it kind of seems like alongside technical innovation, kind of have this other journey of we have to intentionally cause distrust in AI as we develop it. Because people develop things, they love it, and they go right ahead with it. I think there's a famous example of an American city which crunched some numbers and started placing stop and search police officers in predominantly African American districts. That's where the most crime happens. And it was only a few years later, after the damaging effects of that on that neighborhood, that took effect. But actually maybe initially that data was because our police were like inherently prejudiced against African Americans, so they were like arresting them more, and therefore the crime rate spiked.
Yes.
So would you say there is a relationship between causing distrust and innovating that technology, or maybe not?
Okay, so the question is there a relationship between causing distrust and for the innovation? Is it important to do that to some extent? You mentioned the example of an Afro-American neighborhood getting searched more because it was like data that indicated that there was more crime, which was probably not factual. That is like the training data. So the agent can only be as smart as the data you put in. So we have to be very careful. What do we teach it that we don't amplify the little biases that we have? So for example, in visual recognition, so men in kitchen get high proportionally misinterpreted as women because that's what we think that happens, right? So in current systems, and men shopping, well, they're more likely women. So that's where we already started to bake into these systems the biases that we have. That's very, very important that we have quite a diverse team there as well. Perhaps not even just white middle-class citizens who do these things, but really like more diverse backgrounds to question these biases that we have. To be critical with these things is totally right, I think. To do it intentionally, I think there's lots of fear-mongering going on about that. I think there are great things where it could really help as well. But it's good to be critical about these things. I mean, there's like stories like Facebook doing like tests, like testing or manipulating emotions intentionally on 6,000 users and stuff like that. That happens, and that's like, it's shocking. So it's very good to be critical anyway, I think, in any new technology. But it shouldn't hinder us. I think at the moment it's very black and white. I try to show like all these big science fiction things. They're not happening anytime soon, as far as we can tell at the moment. So what are the practical things we can do now? And in this, how can we kind of move forward and test at like low cost, really? And like, I think diverse teams and diverse things is very, very important, because if these machines do their own deductions, then yes, all is in the training data that we give it. So if that has a slight bias, like we've seen in the Microsoft bot, it goes like ballistic, right? So, and that's a big problem. Yeah. Hi.
Hi. Sorry for my alarm going on. You were saying about the anticipated kind of windows when machine learning was going to evolve.
Yeah.
But wasn't there just recently a case where they developed their own language?
Yeah. Yes.
So it's really, these self-programming machines have already kind of happened.
Yeah.
Do you think that was a one-off, or do you think this is happening more?
Yeah.
Or is this
Well, I didn't follow that story completely through, but apparently it went like kind of, they talked like crazy language, like really gibberish, and it was not really useful. So
Speaking between themselves was useful.
for that, yeah, exactly. But it's yeah. That's
And it was useful enough for people to feel the programmers to like kill it. Well, you can't kill the machine, can you? But
Yeah.
that term to use.
Switch it off.
Saves the activity.
Yeah. So that's interesting. That it creates a new language. I mean, kids do that all the time, right? So I mean, but it's not. I think the definition that it goes to the next stage, really, which would be artificial general intelligence, would be that it can take learnings from one field and apply it to another. So I think that even didn't happen there, really, because it didn't do any transfer.
So we didn't know it. So the thing was, it wasn't interpretable to humans.
Yeah, exactly. And then,
That was what was
yeah. I mean, I guess it's an art discipline. It's really interesting. But if we want to build machines that are useful for us, and we want to know for sure they're not dangerous, it's a nice experiment, but it's nothing that's useful for us there, I guess.
I mean, if you didn't follow the story, then that's completely fine. I was just wondering, just on the off chance that you had, and if you had any kind of...
No, I haven't. I'm curious to talk about more about that. Yeah, later. Hi.
So what is your take on the AI ethics board? So in my view, opinion, so there's like, it's linear, so there's basically like the AI ethics board that could be the same weight as like a human rights bill, for example, and then the other end, which is like a business-driven or social investment-driven thing that they kind of have to do on the side. What do you, with your experience, think?
Yeah, so the question is, is it like a policy thing, or is it like a voluntary thing? Is it like that regulates these new contracts that we have with the machines? Yeah, I think that's a really interesting one. We need to figure that out. I mean, it's like I think I think it's very important that we have policies, because we've seen like companies misusing these things. It's like the big companies. Creating like running tests, doing intentional things which they shouldn't do. So it's very, very important that we have like regulations for that. They're self-regulated, I don't know. There are examples where AI is used as well in distributed platforms as well, to how do you call them? Like cooperatives, micro cooperatives, how they like kind of empower smaller organizations as well. And there's I think it's an award, AI for Good, that highlights as well the positive impacts that it could have. So I think that's what we should emphasize on, and we need, of course, policies to keep the whole thing in some usable and non-violent shape. I don't have a good answer for that. Yeah, we have to figure that out, I guess. It's its own conversation, I think. Yeah. Good. Okay. Thank you very much.